Hello everyone. My name is Sugu. I'm the co-creator of Vitess. I'm also a CTO at Planet Scale. Today we're going to be talking about why the cloud is inevitable. But more importantly, what is it that we can do to face this change that is coming up. Okay? So before we go into the details about how to do this, let's think about why this change has happened. If you had come to me like 10 years ago and told me that you built something like Kubernetes, with all these orchestration layers, all these rules, all these new complexities that it brings with it, I would have been extremely skeptical. But come 2020, Kubernetes is now catching fire. Everybody is using it. Everybody is adopting it. So why is Kubernetes getting this popular today? And why was it not relevant before, right? For that, the reason is actually extremely simple. Essentially, CPUs are not getting any faster anymore, and software is continuing to grow. So the only way for you to keep growing is by spreading your software out into different machines. And when you go into this mode, beyond a certain level, you're just going to have just too many machines, too many pieces of software running all over the place. And a human is not capable of keeping track of what is where, like it used to be before. So this is why Kubernetes has become relevant in today's times, because of how wide distributed deployments are nowadays in terms of software. Okay, so there is actually a similar problem happening on the storage side, right? But for a different reason. In storage, the price of storage has dropped to the extent that I can now afford to buy huge amounts of storage at a very low price. I could buy like hundreds of terabytes of data. And what that means is that if I can afford to buy hundreds of terabytes of data, I want to put more data in it and use it to get more results out, analyze things better, right? But the problem with hundreds of terabytes of data is that you cannot hang that under a single machine. You also have to distribute that data. It doesn't fit. Otherwise, you won't get the kind of throughputs that you would expect from data of that size, right? But when you did Kubernetes, right, the problem space it was solving was much simpler. It was just software pieces talking to each other. So it's essentially establishing RPC protocols between them was enough for them to talk to each other. So Kubernetes problem was relatively simple to solve. But when it comes to data, things are a little more complex. Data tends to be in one place. There's relationships that exist between data. So if you decide to distribute that, it is not as straightforward as you distribute software, right? In case of key value stores, in some respect, it's slightly simple because you just shard it and keep sharding. But if you're talking about relational data, there's relationships that exist between them. There's different types of tables, there's foreign keys. So how do you distribute data that is relational in nature, right? There is another problem, which is that software that manages data like MySQL or Postgres, each one has different ways by which they do this management. So the solution that you build for managing MySQL is not going to work for Postgres, for example. In other words, the kind of orchestration that Kubernetes managed to build as generic for software doesn't necessarily work when it comes to building orchestration layers for data. In this case, for example, Vitess is more specifically suited for managing MySQL in terms of orchestration. But then there is another problem. We also have to embrace the changes that are coming up. This orchestration layer has to play well with Kubernetes. And here we are going to use one advantage, which is one feature that Kubernetes has, which is the ability to extend Kubernetes through this thing called operators. So you can essentially make Kubernetes more aware of more things than it was originally built using these operators. They are called CRDs, or custom resource definitions. Using those, you can basically raise the level at which you speak with Kubernetes in terms of YAMLs and etc. Okay, so all of this put together is the nice story that we can build when it comes to moving data into the cloud, into Kubernetes, right? So what do we need to, like today, if you take MySQL, what are the additional orchestration pieces that you have to build in order for it to be cloud friendly, right? We have identified 3 problem areas that you need to solve. It's not just for MySQL, for any storage system, for it to work under Kubernetes, you need to solve, in my opinion, 3 of these areas. One is orchestration, which means orchestration means that bringing up instances, discovering them, handling masters, having replicas, wiring them up together, handling failovers. So all these are in the orchestration area. The next one is distribution. By the fact that your data is now split into smaller parts, some may be individual schemas, some may be sharded databases, you need something that brings it all together and gives the application a more simplified view in terms of its data. It shouldn't have to go and discover all these things. These things may be spread out all over the place, right? So that is the second problem. The third problem, which I will cover in more detail later, is day 3 problem, as in once you have solved the orchestration, once you have this distribution, you're going to be facing the need to keep pushing this data forward with the fact that your business needs are changing and your application is growing, it's scaling more. So you need to be able to keep on transforming this data to keep it relevant to the fact that your application is changing. So those are the 3 areas that need to be addressed for your database to go and live well in the cloud. So let's now first talk about orchestration. And actually, let's think about why, what it would take. Why is it that MySQL cannot just be moved into Kubernetes like software pieces are moving, right? So here is an example. The way you would deploy MySQL on Kubernetes is by putting it in a container and then deploying it as a pod. You deploy it in a pod, and what it does is that by default, it will use your local disk. So you create your database in your local disk, and then you can start sending traffic to it, right? Send it SQL queries, it'll work for you. But the problem is later, Kubernetes is going to come and say, oh, I need to move this pod to another server, so I'm going to shut you down and I'm going to restart you somewhere else. When it does that, the thing that Kubernetes will do is delete or wipe your local disk. In other words, if you restart your MySQL, it's going to start again with no data in it. So that is a problem with just taking MySQL and giving it to Kubernetes. This setup is quite convenient. If you're running tests and stuff, you just launch a pod, run it on local disk, and do your test. Once it's done, you just delete the pod and everything is gone. So it's kind of convenient for certain use cases, but not for production. Right? So what people have started doing is actually not use the internal local storage. Instead, they actually mount a volume. In other words, they deploy only the MySQL in the pod, and it connects to a mounted volume where it stores the data. In this case, if the pod is moved, the data is still outside, more persistent than before. But the problem with moving this data is when you reschedule this pod, MySQL has to come up, mount this volume, and perform a recovery. And this recovery is going to take time, which is going to be a loss of availability. And there is another problem. MySQL itself is tuned for using a local disk. And things are going to behave differently if it has to go through a network boundary to actually read and write its data. If you build an application with this setup right from the get-go, you'll probably be able to work with it. There are people who actually work with this setup. But if you are used to your application, to your MySQL, if you tuned your MySQL to actually use a local disk, this setup may actually be a little uncomfortable to move into. So what is the next possible thing that you can do to run MySQL on Kubernetes? You can say, well, let's do master replica and we can do failover, right? So right here, there is a problem where of identifying a pod specifically. Kubernetes has a few ways, and the most recommended way for a stateful set is what they call it, is actually something called stateful set, where each pod can be individually identified, right? So the app server, you can say pod 0 is the master, and you tell the app server, if you want to write traffic to the master, connect to pod 0 and you can write to it. So this works fine, but the problem is, let's say this master goes down, we could perform a failover. So first of all, if you want to perform a failover, you need an orchestration layer that actually does that failover and repoints the replicas to the new master. So you need something like the orchestrator to do that for you. So that is one glue code that you need to be able to run in Kubernetes. Right? Then there is another problem, is that the app, you have to tell the app server that a failover has happened, and now you need to start writing traffic to pod 1 instead of pod 0. So which means that after the orchestrator has failed over, you have to push config to the app server saying, now start writing to pod 1. Or the other choice is you may need to put a DNS up there somewhere, and then you update the DNS, and then the app server uses that DNS to actually reconnect to the new pod. So those are some of the things, but all that glue code now in other words, you cannot just take MySQL and run it in Kubernetes. You need to start running these additional components to do this orchestration for you. Here is a third scenario, right? You have a master, you have a replica, you want to bring up a new replica. Typically, what would you do is you find a node, you find a node, you bring up MySQL there, you SSH into that node, you then do the restore. There's a lot of manual setup that you do. Kubernetes doesn't like that. It wants everything to come by itself. When you say bring up a pod, all this stuff has to happen automatically, which means that the pod, the automation within the pod needs to know who it is, find the right backup, restore from that. After you restore from the backup, it needs to point to the master, wait for the replication to catch up. So all these things it has to do for this replica to be ready to serve traffic. And then beyond that, once you have reached this point, you have to somehow inform the app server that there is now this new replica that can accept traffic. So again, you need glue code, and then you don't want to be pushing all this config to these app servers. So essentially, this hints at basically that there is a need for a proxy in the middle that manages these changes, these state changes, these pods that are coming up and down, and shield that from the application so that the application can be more focused on its business logic and just send its queries to this proxy, and this proxy can figure out what things go where. So this is essentially another problem that needs to be solved if you are going to move MySQL to Kubernetes. And Vitess has kind of more or less solved these problems for you. It has solved the problem of discovery. When things come up, it can discover them, and there is a mechanism for that. It can handle failovers. You can actually do a backup, and then when you bring up a new pod, the pod would know to actually go fetch the restore from that backup and do all that wiring up, and eventually through the discovery mechanism allow the application to start using it. But we are not stopped there. We actually gone one level beyond. There are things that now developers expect from your software. You don't want to be. They don't like you to handhold the schema deployment, right? If you deploy schema, you have to run this ghost workflow and all these things. So Vitess has started to automate all those things. There is actually a presentation by Shlomi that I would highly recommend you attend, where you can just issue your schema change, DDL, and behind the scenes, just like you would say create table, alter table, you do those things, and then behind the scenes, Vitess will orchestrate this entire deployment for you of the schema with no downtime. So that's a session I would recommend. So the next problem that you want to solve is the problem of distribution of data. If you're going to distribute data into hundreds of machines or thousands of machines, you need something that brings that data together under one umbrella, under one model, as it were. So you want to be able to present a unified view of all this data that is there all over the place. And that is what Vitess solves for you. So on the back end here, you have all these what you call key spaces, right? Key spaces are like a database in MySQL, a schema or a database in MySQL. And then a key space can be unsharded, or you can say, I want to shard this key space, and then it gets deployed onto multiple MySQLs. And this thing can get deployed over multiple data centers, and it could be a pretty huge setup behind the scenes. But there is a VT gate layer that sits in the middle between your app server and these sharded databases. What it will do is, these VT gate layers are stateless, which means that application can connect to any VT gate layer. And for the application, this entire backend appears to you as if it is a single MySQL instance, single enormous MySQL instance. And then if you create new key spaces, no problem, they'll start appearing as new databases here. You reshard your key space, most of your queries will continue to work. Some queries may have to be rewritten because they are not cross-shard friendly. So there is some impact, but it is mostly isolated from the fact that you are making huge changes in the backend. Right? So this is the next problem that Vitess solves for you, is continues to give you a unified view of an extremely highly distributed data on the backend. The next part is transformation. This is what we believe is the biggest differentiator that Vitess gives for you. What happens is that when you distribute the data to the extent, right, especially if you are going hundreds and thousands, tens of thousands of nodes, you're going to have to manage that data. That data is not going to be just static. Right? There's business needs that are going to change. Sometimes data is going to grow too big. You have to split it. How do you manage all those things? Replication is the piece of technology, the underlying piece of technology in Vitess that helps you do all these things. Here are some use cases, for example. In relational data, you cannot expect all relationships to be purely hierarchical. Relational data, by definition, allows you to have many-to-many relationships. For example, let's say you are a retail establishment. You may have people may be placing orders. The order will have multiple foreign keys. It's going to have foreign keys into a product. It's going to have foreign keys into a merchant. It has foreign key into the customer, right? If it's a marketplace, there are merchants that are selling. So if you decide to shard this data, where do you put this order row? Where do you co-locate, right? If you say, I want to co-locate this order row with the merchant, then you cannot efficiently perform a join the customer with their order. It's going to become a cross-shard jump. If you put it to the customer, then the merchant side becomes a cross-shard jump. In Vitess, you can actually have the best of both worlds. You can say, I want to create the order row, sharded, co-located with the user that's creating it. But I say, I also want you to materialize this row against the merchant that it was bought from, right? So in which case, this basically, so as soon as you create a row on the user side, that row will immediately get recreated or materialized on the merchant side. You change the row on the user side, it will be updated on the merchant side. And then when you do a join, you will get the best of both worlds, which means that it will be a local join, whether you join in the user or with the merchant, right? So this is one great example of use case. You can reshard, right? When your shard gets too big, you can do replication where you will create two new shards of your original shard, replicate the data out, split that into two, and then cut over the traffic to the new shards. Sometimes you may have decided on the wrong sharding key. You realize, oh my God, this is not the correct sharding key. I should have sharded it using that other key. Things would have been a lot more efficient. Vitess allows you to change your mind. You can say, oh, okay, if you want to change your sharding key, it's fine. Give your statement. We will actually convert this source table into a target table, shard it differently, and we'll cut over the traffic for you, right? So you can do that using Vitess. It is kind of similar to materialized views, but in this case, it is used for cutting over traffic. from one to another. You can migrate data. Let's say your data is in an old MySQL instance and you want to get out of that, you want to use the more up-to-date settings that Vitess has. You can bring up a Vitess instance and say, point it at that MySQL and say, suck all the data in. And while your application is writing data to the old MySQL, Vitess will keep this new data up to date. And at some point of time, you can cut the traffic over to the new data. You can also stream everything out. Let's say you have an analytics system. You may have ClickHouse on the other side. You may have Snowflake, whatever, right? You can stream data out of Vitess into those analytics system to perform your analytics queries. There's a customer of us that actually used vReplication to upgrade MySQL versions completely safely. What they did was this was actually in Aurora. They were running on Aurora 5.6. They wanted to migrate to 5.7. So they set up a new Aurora cluster, used vReplication to replicate the entire data over to the new one, cut over to the new Aurora, and after the cutover, they reversed replication, just in case you have to cut back because if there are issues, right? So things like this you can do with vReplication. And I'll talk about the anonymized PII, which is a very cool use case in detail later. So Slack, for example, had to do migrate. So they were already running on Vitess, but only a portion of their databases was running. They still had over 1,000 shards that were left in legacy MySQL instances. They needed to migrate those. There were like over hundreds of terabytes of data, and they were serving like hundreds of thousands of QPS. And all that migration had to be moved into Vitess. What did they do is their estimate was like, this is going to be a huge project. Like they were estimating 4 engineers, 3 to 5 years to migrate this. And this, in my opinion, was aggressive. But they used vReplication. They used 1 engineer in 1 year. Almost all the data has now been migrated, right? And that, with zero downtime, completely transparent to the application. These are the kinds of cool things you can do with vReplication. So Yelp actually had a completely different use case. To them, production type of, they want to test, their developers are used to testing with production type of data, right? But production contains PII. So what they did was, they used actually vReplication to anonymize anything that was PII. So the reason why you can do this with vReplication is because the core technology of vReplication allows you to express the materialization rule as a select statement. So you can say, it's like creating a view, and then you specify the select statement for the view, except in Vitess, it actually materializes that view for you, and not just within one key space. It can be across databases, it can be sharded, it can be any way you like. But then you get the full power of SQL for this materialization. So what Yelp did was they used actually MySQL's hashing functions to anonymize this PII data. And they had like over 800 tables from a single database, out of which 120 of them had PII. And they ended up creating 700 streams from the source to the target through vReplication. The reason why it was called vReplication is because it actually does this materialization by subscribing to the binlog stream and incrementally applying the changes by observing what it saw in the binlog stream. So which is extremely powerful, which means that vReplication is very efficient and very fast. You can incrementally apply every change, very up to date, which means that as soon as a change happens on the source, it goes as fast as basically regular MySQL replication. So ultimately, the way we want you to see data as, you want to see data as something that you can refactor and change as you go. You don't want to be stuck with decisions that you are. Like the ease with which you go refactor code, you should be able to go to the data and just refactor it, just like you would do code. And in this, we have some really, really cool thoughts that we are saying. Like, for example, let's say you want to split a table. You go to Vitess, say, I want to split this table into 2. And Vitess will say, okay, now you can rewrite your code as if you split the table. And so you rewrite your code. What Vitess can do is continue to send that second table access to the original table. And then it can do the materialization. And then once the materialization is done, it can cut over traffic for you completely transparent to your application. And let's say after cutting over, you see some trouble, you can cut back because the source is also kept up to date. So because of these cool functionalities that you can add in Vitess, this makes it an extremely powerful tool for you to actually get both the developer velocity and overall feature velocity. So these are cool things that are going to be coming up in Vitess soon. So if you look at the market out there, you will see there are solutions that are coming up in the cluster management area. There are solutions coming up in sharded query serving or distributed SQL area. But vReplication is the secret sauce in Vitess that actually gives you huge power, huge flexibility in terms of things you can do with it. And these are things that you will get as you, and you can use these three things to also migrate your data into the cloud. And these are not things that we are theorizing as things that need. These are things that users of Vitess have adopted Vitess, have used it, pounded it to really, really enormous QPS. And when they were running at this scale, these are the problems they faced, and these are solutions that we built in Vitess to solve these problems. And these companies are extremely excited to use these problems. And even more cool, these are companies that are building technology using the future of the future stack of the world, right? The Squares, the Slacks, the GitHubs, the Pinterests. These are all companies that are building using the newer ways of building software. So it's kind of cool that these companies are adopting Vitess. And there's actually a lot more that are in use. We'll update these as these companies add themselves to the list of adopters in Vitess. So before I conclude, I would highly recommend attending Shlomi's talk that is coming up soon. If you are planning to use Vitess, I would also recommend you join our Vitess Slack and feel free to ask questions. We love talking about all these things that you can do with Vitess. And now I'm open for questions.